Okay, so today we're going to cover section 2. Today we're going to talk about areas of circles and sectors. Yesterday when we were talking about that piece of pizza, we were talking only about the length of the crust. Now we're going to talk about the area of the entire slice of pizza. So here is the first formula that you can add to your list of formulas, and it's the area of a circle. The area of the circle is pi times the square of the radius. So if you're asked to leave it in terms of pi, you're just going to square the radius and then put the pi symbol. So for example, if I told you this radius had a length of, say, 5, my answer here would be 5 squared pi, and you would have to square it and then put the pi symbol. So if it's asking you to leave it in terms of pi, that's all you do. Now, if I tell you use 3.14 for pi, then we'd actually have to multiply it. Everybody good on this slide? Let's look at the next one. Wait, okay. Next. The region bounded by 2 radii and their intercepted arc of the circle. So this is called the sector of a circle. So think of this as a piece of pizza. So this is our piece of pizza, which is going to be the sector of the circle. So yesterday we talked about the crust. Today we're talking about the whole slice of pizza. Now we're going to talk about theorem 11.3, which is the area of the sector. So basically it's the same thing that we did yesterday. The only difference is, see right here, this is going to be the area formula. Yesterday it was the circumference formula. So again, we're still taking the measure of that arc in degrees, divide it by 360, and then multiply it by the area formula. So the area of a sector is the ratio of the area of a sector of a circle to the area of the whole circle, pi r squared, which is equal to the ratio of the measure of the intercepted arc to 360. So basically you're taking the arc measure in degrees, divide that by 360, and then you're multiplying it by the area of the circle. And the formula for area of a circle is just pi r squared. So you're just going to put times pi r squared.
Wait, what's area of the sector?
I'm sorry?
What's area of the sector?
The area of the sector is just, instead of talking about the area of the whole circle here, the area of the sector is just the area of the piece of pizza.
So is that just like the shaded part?
Yes. So it's the area of the shaded part. Exactly. So that's what the area of a sector is. We're only talking about a small shaded part of the circle because it's only a portion of the whole area. Okay, so here they're telling us the radius of the circle is 3 centimeters. It wants us to find the area of the sector determined by the given arc. It wants us to leave our answers in terms of pi. So remember, our formula is this. We're going to take the area of the sector is equal to the measure of the arc. Oh, that's the number that they're giving you, times pi r squared. And in all of these, our radius is 3. So when we go to do this, we're going to do 50 over 360 times 3 squared pi. 3 squared turns into 9. So I'm going to do, and I could cross these zeros off. So I'm going to make it 5 over 36 times 9 pi. I can also simplify the 9 and the 36 and make it a 1 and make this a 4. So my final answer here is going to be 5 pi over 4. And these are centimeters squared.
Could you get like the actual calculation of it?
No, because the instruction said leave it in terms of pi. And this is probably what I'm going to do on the test. So we don't need a calculator. Okay, so 5 pi over 4 centimeters. If you write your answer as 5 over 4 and then put the pi behind it, that's fine. Just know that the pi can't be in the denominator. Okay, number 20 degrees, sorry, part B. So here we're going to do 20 over 360. And it's 3 squared pi, so I'm just going to make it 9 pi. I could simplify, I could cut my zeros off, and then make this a 1, make this a 4, and then I can still simplify it even more, and I can make this a 2 and a 1. So my final answer here is going to be pi over 2 centimeters squared. Or you could also say 1/2 pi centimeters squared. Either one. Now, if you don't like simplifying diagonally, you could multiply it out. But again, we're probably not using a calculator, and then you're going to have to simplify a really huge fraction. Okay, for part C, again, I'm going to put 140 over 360, multiply it by the area, which is 3 squared pi. So 3 squared is 9 pi. Again, I'm going to cut my zeros off, so I've got a little bit smaller fraction. Let me switch to black so you can see it better. 14 over 36 times 9 pi. I can either simplify the 14 over 36, but since I've been simplifying the 9 and the 36 all along, I'll just keep doing that, make that a 4. So now I'm at 14 pi over 4. I can still simplify one more time and make it 7 pi over 2 centimeters squared. Part D, same thing. 210 over 360 times 9 pi, because it's 3 squared. Cut off the zeros. Again, simplify the 36 and the 9. Now I'm at 21 over 4. I can't simplify 21 over 4, so I'm going to leave it 21 pi over 4 centimeters squared. Sorry. So basically what it's asking us to find is, hold on, let's see this. What I'm referring to in this question is this area that's right in here. This is the sector that I want to find. So what we're going to need to do is we're going to need to find the area of the triangle and then subtract it out. So basically what we need to do here, let's see if we can write it up top here, is we're going to find the area of the sector, and let me write it, area of the sector, and subtract out area of the triangle. And then that'll give us the piece that I just highlighted here. So I'm going to find the area of the entire sector. So like this whole piece of pizza. And then subtract out the triangle. So first let's find the area of the sector. We just did a bunch of those. So we're going to do the 120 over 360 times the radius squared times pi. That's going to give us this part of what we need. So 6 squared is 36 pi. And then here, if I cross off the zeros, Now I'm at 12 over 36. Notice I can simplify the 36's. So the area of my sector is going to be 12 pi. So far I've got that part. Now I've got to work with that triangle. Now, yesterday we talked about the formula for area of a triangle, and it was base times height divided by 2, or 1/2 base height. Now notice in my figure, I've got the base, but I don't have the height. Okay, I can't have a slant height. I need a height that's near a right angle. So let me redraw the triangle over here, and we're going to have to divide this up and draw in an altitude to get the height. So now this is my triangle, A, B, C. If I draw in the height here, and I knew that this height is going to bisect this 120-degree angle, and I've got 60 degrees here, I've now turned it into a special right triangle. So now I have a 60, a 30, and a 90. So now we need to remember the rules for the special right triangle. Remember, opposite 30 is A, opposite 90 is 2A, and opposite 60 is A root 3. Now, I already know that my leg here is 6, so 2A equals 6. I need to do 2A equals 6, solve for A, divide it. My A equals 3. So this leg over here is going to be 3 root 3. So over here I got a 3 root 3 and a 3 root 3. And then I know A, the height of it is 3. So now to find the base, so here is, let me highlight this. This is the base, this is the height. So the height's over here, it's at 3. My base is going to be 3 root 3 plus 3 root 3, which gives me 6 root 3. So over here in my triangle, the base is 6 root 3, and the height of this triangle is going to be 3. So to find the area of the triangle, I'm going to do 3 times 6 root 3 divide by 2, or times by 1/2. I could get 18 root 3 over 2, simplify this, and the area of my triangle is 9 root 3. So now in terms of pi, I take this answer and subtract it. And there's my area of the shaded region. So 12 pi minus 9 root 3.